Hello everybody, welcome to Deeksha Online. We had already studied the synopsis relating to laws of motion. Now it's the time to go through some numerical examples to understand the applications of all the concepts that we learned. Example number 1. In a rocket of mass 1000 kg, fuel is consumed at a rate of 40 kg per second. The velocity of the gases ejected from the rocket is 5 into 10 to the power of 4 meter per second. The thrust on the rocket is. Let us see how to solve this problem. The question says the mass of the rocket is 1000 kg and the fuel is consumed at a rate of 40 kg per second. He has also given us the velocity of the gases ejected, which is 5 into 10 to the power of 4 meter per second. The thrust on the rocket. Now, you may wish to recall that the thrust on the rocket F is nothing but V dm divided by dt. Is that correct? Yes. Now, what is the velocity? The velocity is 5 into 10 to the power of 4 into dm by dt. What is the value of dm by dt? 40. So this becomes, how much is that? Is it 2 into 10 to the power of 6? Yes. So 2 into 10 to the power of 6 Newton. That is the thrust on the rocket. So our answer is A. 2 into 10 to the power of 6. That is, answer is C. C is the correct choice. Example number 2. Bullets of mass 0.03 kg each hit a plate at the rate of 200 bullets per second with a velocity of 50 meter per second and reflect back with a velocity of 30 meter per second. The average force in Newton acting on the plate is. He has given us the mass of each bullet and he has also told us how many bullets are striking per second and the velocity of each bullet. And of course, the recoil speed of each bullet, or rather the speed with which they come back, is also given. The average force acting on the plate is to be found out. You know, from Newton's laws of motion, the change in momentum can be related to force, isn't it? So we can write force is equal to rate of change of momentum. If I consider one such bullet, this is m into v minus u divided by delta t. That's right. This is the change in momentum of one bullet, which rate of change of one bullet. And this is for one bullet, and if I consider n bullets, then it becomes nm v minus u divided by delta t. Is that correct? Yes. nm v minus u divided by delta t. Now, he has told us how many bullets are striking per unit time. This is already given to us. So, how much is that? This is n divided by delta t is 200 into mass of each bullet is 0.03 kg into v minus u 50 minus 30, and it further simplifies to, you can notice that there is one important thing to be kept in mind. This 30 itself is to be taken with a negative sign. You should be little careful here. This 30 is to be taken with negative sign. That means if I write it correctly, 200 into 0.03 into 50 minus of minus 30. Why so? It's because the bullets are traveling along this direction. They are striking the plate and they are returning. So initial velocity is along this direction, final velocity is in the opposite direction. So let us simplify this. This becomes, how much is that? 200 into 0.03 into, this is 50 plus 30. Is that correct? Yes. So this becomes 480 Newton. 480 Newton, that is the force exerted on this set of arrangement. That is, the force exerted on the plate is 480 newtons. So the correct answer is 480 newtons, D, option D. Example 3. A monkey climbs up and another monkey climbs down a rope hanging from a tree with the same uniform acceleration separately. If the respective masses of the monkeys are in the ratio 2:3, the common acceleration must be. A monkey climbs up and another monkey climbs down a rope hanging from a tree. So here is the arrangement. Okay, just assume that there is a rope and this monkey is climbing up while the other monkey is climbing down, 1 and 2. So I'll call them their masses as m1 and m2 respectively. Now let us assume that T is the tension in the rope. Now for this monkey, its weight is downwards, tension T is upwards, and it is accelerating up. While for the other, M2G is downwards, T is upwards, and its acceleration is downwards. Is that correct? This is 1, this is 2. So if we write the equations of motion, what do we have? We have T minus m1g is equal to m1a. That's the equation number 1 for the first one. While for the second, what is our equation? Our equation must be m2g minus t is equal to m2a. That's our equation number 2. So if I simplify it further, what do I get? I get A is equal to, you can simplify it further here, we can add, say for example here I can add equation 1 and equation 2, 1 plus 2. What is that 1 plus 2? Then m1g plus m2g, is that correct? m2g minus m1g, m2g minus m1g is equal to m1 plus m2 into a, or a is equal to m2 minus m1 into g divided by m1 plus m2. So if I look at their masses are in the ratio 2:3. So I can write m1 divided by m2 is equal to 2/3. So let me divide this equation by m2, that is the right hand side of this equation. So this is equal to 1 minus m1 by m2 into g divided by 1 plus, that is m1 divided by m2 plus 1. 1 minus 2/3 whole divided by 1 plus 2/3 into g. So what is that? This is nothing but, how much did we get? 3 minus 2, 1, and in the denominator we have 5/3 g, or this is equal to g divided by 5. So g divided by 5. Alternatively, you can use this shortcut. What is that shortcut? The shortcut is something like this. If I consider this arrangement, m1 is its mass, m2 is its mass, then if this is accelerating down, then the acceleration of the system is net pulling force divided by net mass or the total mass which is moving. That is nothing but m2 minus m1 into g divided by m2 or m1 plus m2. This is much easier to handle. And again, because the masses are not directly given, rather their ratios are given, I am going to write it as 1 minus m1 by m2 divided by 1 plus m1 divided by m2 into g, and upon substitution we get g divided by 5. We get g divided by 5. Is that correct? Yes. Question number 4. A block is kept on a frictionless inclined surface with angle of inclination alpha as shown. The inclined plane is given an acceleration a to keep the block stationary. Then a is equal to. Okay, look at this arrangement. The inclined plane is given a horizontal acceleration, and thus we need to find out the value of a to keep the block in equilibrium. Let us see how to do this. Now, if I draw the diagram showing the construction, this is of course alpha, this is the inclined plane, and this is the block of mass m. So what are all the forces acting? The forces are mg, which can be resolved into components, and I have mg cos alpha and mg sin alpha. Now these are the forces, and of course normal reaction is present along this direction. Now if I am standing on this inclined plane and describing the motion, then there must be a pseudo force acting on the block. What is that pseudo force? It's an imaginary force. What is the magnitude of the pseudo force? Mass of the block into acceleration of the frame. What's the direction of the pseudo force? Opposite to that of the acceleration of the frame. So the frame is moving towards right, therefore this must experience a pseudo force towards left, that is ma. So now we will resolve that ma also into components. If we resolve ma into components, what do we have? We have ma sin alpha, is that correct? Ma sin alpha along this direction, and mg, this is ma cos alpha, rather, sorry for that mistake, ma cos alpha, and this is mg sin alpha. So if I consider this, this has mg sin alpha and ma cos alpha. And what are all the forces along these two directions? N is present along this direction, and I have mg sin alpha plus m a sin alpha, ma sin alpha. So if the system is in equilibrium, then I notice that these two forces must be equal. Which are the forces? mg sin alpha and ma cos alpha must be equal and opposite. So I have ma cos alpha is equal to mg sin alpha, or a is equal to g sin alpha by cos alpha, that is nothing but g tan alpha. So g tan alpha is the acceleration required to keep the block on the inclined plane stationary with respect to the block. That is our first option. So option A is the correct one. Example number 5. A block of mass m is resting on a smooth horizontal surface. One end of a uniform rope of mass m by 3 is fixed to the block, which is pulled in the horizontal direction by applying a force F at the other end. The tension in the middle part of the rope, is okay. Now let us look at this arrangement. Let us draw the diagram. This is a block of mass m, and here is a string or rope of mass m by 3, and a force F is exerted here, that is the force acting on this one. Now the question is, what is the tension at its midpoint? Now let us find the tension. To find out the tension, we first get the acceleration. What is the acceleration? The acceleration is net force divided by net mass, that is F divided by m plus m by 3, which is nothing but 3 by 4 F by m. That's the acceleration of the entire system. Now, if I consider this arrangement here, we are required to find the tension at this point, and this is of mass m by 3. So now I'll consider this point. So notice that the mass of this part is m by 6, the mass of this part is m by 6. So it is good enough if I consider this portion alone. That means now it is the tension which is pulling these two together, correct? So this is of mass m, this is of mass m by 3, tension is pulling it along this direction. So what is that equal to? So the tension is equal to its mass, that is m plus m by 6, that is m by 6 here, into acceleration. So what is that equal to? That is nothing but, how much is that? 7m by 6 into acceleration. The acceleration has already been calculated as 3f divided by 4m, and upon simplification what do we get? M and m cancel, and it is nothing but 7 by 8f. So the tension at the midpoint, at the point A or at the midpoint, is equal to 7 by 8f. Here you may wish to calculate the tension at various points. For example, if you want to find the tension at this point, what is it? The tension at this point will be equal to m plus m by 3 into acceleration at this point. Suppose I want to calculate the tension at this point. The tension at this point is simply m into E, correct? Suppose I want to calculate the tension at this point, that is, for example, 1/3 distance. What is that? Here it is m plus 1/3 of m by 3, sorry, 2/3 of m by 3. Why 2/3? Because this is 1/3. I marked it as 1/3. So if it is 1/3 of m by 3 into acceleration. That's right. So depending on the position under consideration, you can find out the tension appropriately. So for the present problem, our answer is 7f divided by 8. That is option D, of course. Question number 6. A boy of mass 40 kg wants to climb up a rope hanging vertically. The rope can withstand a maximum tension of 500 Newton. What is the maximum acceleration with which the boy can climb the rope? Read the problem carefully. Boy wants to climb. The rope has a certain maximum braking tension, and the maximum acceleration with which the boy can climb is to be calculated. Good. Now, this is the arrangement. We had discussed a similar concept in the synopsis part, right? Now, if the acceleration of this is A, what is the tension? The tension is equal to, is it m into g plus A? Shall we write it directly? Yes. But you also know that the maximum tension is equal to 500 Newton according to the problem. So, I should be able to write 500 is equal to, what should I get? 500 is equal to m into g plus A. Is that correct? Yes. So, 500 is equal to m into g plus A. M is equal to 40. I'll take g as 10 and this is A. So, how much is that? The acceleration A is equal to 500, that is 50 by 4, which is nothing but 12.5 minus 10, that is nothing but 2.5 meter per second squared. So, the acceleration, the maximum acceleration with which the boy can climb up the string or rope is 2.5 meter per second squared. What if the acceleration of the boy is more than this? What will happen? If the acceleration of the boy is more than this, the string or the rope will snap. So, our correct choice is C, 2.5 meter per second square. Example number 7. A motor car is moving at a speed of 30 meter per second on a circular path of radius 500 meter. Its speed is increasing at a rate of 2 meter per second square. What is its resultant acceleration? Okay. So, this is the arrangement. Here is a particle or say a car which is moving along circular track. This is the instantaneous position. At its instantaneous position, the acceleration or say the speed is increasing at a rate of 2 meter per second square. Isn't it the tangential acceleration? Yes. And because the particle is in circular motion, it also possesses radial acceleration, which is also known as centripetal acceleration. What is that radial acceleration or centripetal acceleration given by? Is it v square by r? Yes. V square divided by r. 30 square divided by radius is 500 meter. And what do we have? We have 900 divided by 500. That is 9 divided by 5. And what are the directions of these two accelerations? Perpendicular. Radial acceleration and tangential acceleration are perpendicular. Therefore, the net acceleration of this is square root of AR square plus AT square, which is nothing but AR. What is the radial acceleration? That is 9 divided by 5 whole square plus tangential acceleration. What is the tangential acceleration? That is 2. So, 2 square, correct? So, tangential acceleration is 2, therefore, 2 square. And you can simplify it further. You have 81 divided by 25 plus 4. So, this is square root of 181 divided by 25. And you can simplify it further. Root of 25 is 5 and root of 181. So, if upon simplification you get 2.7 meter per second square. So, the net acceleration of this system or this motor car is 2.7 meter per second square. Observe an important thing in this problem. The numerical options are close to each other, so it is important to calculate it properly. If their values are far apart, then an approximate answer would have been okay, but that is not the case here. 2.7 meter per second square is our answer, corresponding to option B. Question number 8. A block of mass m1 lies on a smooth horizontal table and is connected to another freely hanging block of mass m2 by a light inextensible string passing over a smooth fixed pulley situated at the edge of the table as shown. Initially, the system is at rest with m1 at a distance d from the pulley. The time taken for m1 to reach the pulley is. Okay. So, this is the construction. The block is here. At what distance is it present from the pulley? It is located at a distance d. And another block of mass m2 is here, this being m1. Now, we are supposed to find the time taken by m1 to reach the pulley, that means cover a distance of d. Now, how to solve this problem? We know how to calculate the acceleration of the system. And is that acceleration a uniform acceleration or variable acceleration? Yes, it is uniform acceleration. If the acceleration is uniform, then can we use our equations of motion like v is equal to u plus at, s is equal to ut plus half at square, etc.? Yes. So, we will use those equations. To use this equation, first let me get the acceleration. What is that acceleration? It is net pulling force divided by net mass. What is the net pulling force here? I am going to write it directly. It turns out to be m2. The pulling force is because of this mass, m2g divided by m1 plus m2. That is the acceleration. Isn't it? Yes. Now, we can use the equations of motion. Which equation should I use? I know the distance it travels, so I know the acceleration. I also know that initially it was at rest. That's also known to us. And I want to find out the time. Clearly, the second equation of motion can be used. Ut plus half at square. Now, s is d, u is 0, half a. Acceleration is m2g divided by m1 plus m2 into t square. Therefore, we have 2d m1 plus m2 divided by m2g. This is our expression for the time required, 2d into m1 plus m2 divided by m2g. Simple problem. We had used two concepts here. Which two concepts? The pulley mass system concept and the fact that a uniformly accelerated motion can be described using the general equations like v is equal to u plus at, etc. And it corresponds to option B. Example 9. A block of mass m is connected to another block of mass capital M by a massless string of spring constant K. The blocks are kept on a smooth horizontal plane. Initially, the blocks are at rest and the spring is unstretched. Then a constant force F acts acting on the block of mass capital M to pull it. Find the force on the block of mass small m. Okay. Here is the construction M and there is a spring and this is block of mass capital M and a force F pulls it. Now the question is, what is the force on this block? What is the force on this block? That is our question. So as always, first let me get the acceleration of the system. What is the acceleration of the system? Net force applied by net mass which is moving, F divided by m plus capital M. Now, if I consider this block, you know, this block is accelerating, correct? This block is accelerating. Now, if this block is accelerating at an acceleration a, what must be the force on this one? So, force on this block of mass m. Should it be mass into acceleration? Yes. So force on this block of mass m is equal to mass into acceleration, that is m into F divided by m plus m. M into F divided by m plus m. So observe an important thing. This is what happens when a force of F is acting on the system continuously. That's right. So the force exerted is m into F divided by m plus m. And which option does it correspond to? Yes, the last option. It corresponds to the last option, that is D. Example 10. If the force on a rocket moving with a velocity of 300 meter per second is 210 Newton, then the rate of combustion of the fuel is, okay. So once again, it's a simple substitution type problem. Force, that is thrust, is equal to V into dm divided by dt. And of course, we also have the second term, m into dv divided by dt, but at present this part does not come into picture. Moving with a velocity, that means its velocity is constant. So clearly this part becomes 0. And now we are asked to find out the rate of combustion of the fuel. When I say rate of combustion of the fuel, what does it mean? It means how much fuel is consumed per unit time, which means the value of dm by dt. That's the rate at which the mass is lost. And clearly that must be equal to F divided by V. So we can substitute here. Dm divided by dt is equal to F divided by m. What is that F? The force is 210 and the mass is how much? Oh sorry, this is nothing but V, not m. So this is 300. F is equal to V dm by dt, therefore this becomes V. So 210 divided by 300, so this is nothing but 0.7 kg per second. So the rate at which the mass is lost is 0.7 kg per second. Which option does it correspond to? Yes, the option C. Example 11. A particle of mass 5 kg moves in a circle of radius 20 centimeter. Its linear speed at a time t is given by v is equal to 4t, t is in second and v is in meter per second. Find the net force acting on the particle at t is equal to 0.5 seconds. Okay. Now particle is here, it is in a circular track, and at this instant the velocity is given by 4t, which means that is it a varying speed or constant speed? It is a varying speed. What does it mean? It means the particle has tangential acceleration and radial acceleration. Therefore the net acceleration is square root of at square plus ar square, and I can find out the net force using mass into net acceleration. So I need to get the value of net acceleration. To get the net acceleration, I need tangential and radial acceleration. Let us first take care of these two things. So radial acceleration, you know, is v square divided by r. V is 4t, 4 into 0.5. Why 0.5? At t is equal to 0.5. 20 centimeter, so 0.2. 4 into 0.5 is 2, 2 square is 4, 4 divided by 0.2 is 20. So 20 meter per second square is the radial acceleration. And the tangential acceleration. What is the tangential acceleration equal to? Is it dv divided by dt? Yes. So we need to differentiate that velocity, which is 4t. Differential of 4t is 4 itself. So tangential acceleration is 4 meter per second square. Therefore, F net is equal to m square root of ar square plus at square, which is, what is the mass? The mass is 5 kg into square root of ar square, which is 20 square, plus this is 4 square, and you may notice that this becomes 5 square root of, this is 16, correct? 20 square plus 40 square, 16 plus 400, 416. Now what can we do? We can take this some term outside. So this is 5 square root of 416. Shall we take 16 outside? Yes, it becomes 5 into 4, and what are we left with? Yes, 26. So 26, that gives me 20 root 26. So 20 root 26 Newton is the force acting on this. And which option does it correspond to? 20 root 26? Yes, it corresponds to option D. All right. Next one. A body of mass 5 kg starts from the origin with an initial velocity u is equal to 30I plus 40J meter per second. If a constant force minus 6I minus 5J Newton acts on the body, the time in which the y component of the velocity becomes 0 is. Okay. So now the y component of the velocity should become 0. What does that mean? It means that Vy should become 0. But we know Vy is given by Uy plus Ay into t. Is that correct? Now, do I know the value of Uy? Yes. What is that equal to? Uy is equal to 40. And do I know the value of Ay? Not directly. I can write as Fy divided by mass. What is the force? That is minus 5. What is the mass? 5. So what do I have? This is nothing but 1 meter per second square with a negative sign, which simply means that the particle is decelerating. So what do I have? Vy is equal to Uy minus Ay into t. So 0 is equal to Uy. Uy is equal to 40 minus Ay is 1, and the time required is t. Therefore, the time required is 40 seconds. So the time required for the particle to come to the state in which the y component of the velocity becomes 0 is t is equal to 40 seconds. And does it correspond to option C? Yes. Example number 13. Two masses m1 and m2 are accelerated uniformly on a frictionless surface as shown in the figure. The ratio of the tensions T1 by T2 is. Okay, let us see what is that. Simple problem, not a difficult one. This is a string and this is of mass m1, this is of mass m2, T2, T1. Now, the entire system accelerates towards right with an acceleration e. So, can I write this T1 as M1A? Yes, T1 can be written as M1A. And what about T2? T2 is equal to, it is M1 plus M2 into A. So, what is the ratio T1 divided by T2? T1 divided by T2 is equal to M1 divided by M1 plus M2. M1 divided by M1 plus M2. Very simple calculation. Notice that I don't even need not know the value of acceleration. Ultimately, the acceleration term doesn't appear in the equation at all because we are taking the ratio. So, does it correspond to option D? Yes. So, with that problem, we come to the end of this session. Please practice homework problems and problems from various other sources till you get a hold on all these cases. Thank you and have a nice time ahead.